Hello everyone, Cody here. We're going to be talking about convolutional neural nets, or CNNs as they're commonly called. Now, CNNs are notorious for image classifications, whether it's for dog breeds, whether it's for handwritten numbers or handwritten letters, or whether it's dog versus cat. They're just notorious for that. And the reason why is because CNNs are really good at understanding the spatial relationship of data, which is this kind of high level way of saying that CNNs are basically just all vector multiplications. And uh, and the reason why images work so well for that is because we see an image similar to this, but the computer sees just a series of numbers spit all the way across. So this upper left, very top pixel right here is way up there. And because of that, it's really good to be used for a CNN because CNNs love this kind of stuff where there's a fixed vector and information makes sense in regards to where everything else is stored. So another example of how CNNs could be used would be for like a time series. So predicting weather at a specific location over a period of time makes the data very specific, right? Because we have seasons. You know, if we were to scramble up the seasons or if we were to scramble up the pixels, we wouldn't be able to make heads or tails of either. And that's why it's so important with CNNs is to use for time series or for classification problems, especially with images, is because where that data sits matters. If we were just to throw all these pixels around, it would make no sense. We would just see a bunch of wild colors and it would make absolutely no sense. So just bear with me. This is going to seem a little confusing at first, and then hopefully it makes more sense. So there's three layers, or there's three layers to building a CNN. The first one is the convolutional layers, and this is where we do feature mapping. What we do is the CNN just kind of says, oh, I'm looking for specific things in the image itself, and it runs across it from left to right, and it's taking notes into its own vector, right? Then there's the pooling layer, which is taking those mathematical notes and applying it again to an even smaller vector. And these two, convolutional layers and pooling layers, kind of go back and forth, and they just kind of keep rotating through. And depending on the complexity or the data amount, you can have multiple layers configured in different ways with convolutional pooling. And then the last one, which is considered a fully connected layer, that's where we just kind of smush everything together and we just make it a prediction for, in the case of classification, we just make a prediction of whether it's a 1 or a 0, or whether it's a dog or a cat. It's just making a prediction, squishing it down. And the reason why you need a fully connected layer, we'll go into this layer later, but it's basically just because of how the math works out. It's not neat, so the fully connected layer kind of smushes it all down and then just gives you a spit out of it. So when you're looking for features, what really happens is you take this image, and this is maybe labeled as a dog, and there's a box that goes around a series of these pixels, and then it's multiplied by some kind of feature that it's trying to find. It could be vertical lines, horizontal lines, it could be circles, it can be more advanced things, such as like kind of looking for what we would consider an eye or an ear. It's the nature of deep learning allows the CNNs to kind of scan through these things and do a bunch of multiplication. So for example, let's take a look at this mouse. So this is labeled as a mouse in our training data sets. And what would happen is the CNN would start in the upper left-hand corner, and it would do a mathematical equation on this particular section. And then would move over however many pixels we want it to. The general rule of thumb is 1. And this is called a stride. So if your stride is 1, it would move over 1 pixel, and it would do a mathematical formula. It'd move over 1 pixel. It'd do the math again. It'd move over 1 pixel, do the math again. It would do this all the way across the image until it got to the right side, and then would go down 1, and it would repeat the process over and over and over again. Now, it's kind of complicated to explain this, but by the time we get done, this is going to make a little bit of sense, but for me it took a couple times and then some practice to actually get it. So let's take a look at this yellow box. So that's right here. Okay. So in this yellow box, the computer sees a series of numbers, 0, 0, 0, 0, 0 till 30. Okay. And it goes all the way down to the right, all this stuff. So it sees that. What the CNN is trying to do is create a filter to run across to see what numbers come of it. So for this specific filter, it's looking for a curve. So this is a curve detecting filter. And for the curve detecting filter, it's zeros all the way until it gets to kind of this 30, and then it just arcs down into this low 30, and it stops right there because it's looking for a specific type of curve. So this is a very concrete, specific filter right here. There's a bunch of other filters, but for this one, we're using this specific one, and CNNs are very concrete. And so if it doesn't see this type of curve, it doesn't see it. And when I say see it, I mean math-wise, it doesn't see it. So we look at this box, and all we're doing is just doing multiplications. We're just doing vector multiplications of these two vectors, where this vector right here is the filter, and this vector right here is the relationship of the image. So we're doing all this math, and it comes up to a pretty big number. So the larger the number is on a convolutional layer, the more likely that that specific feature is being detected. So if we look at this, it does kind of look a little bit like that curve, and we can see it in the math when you do it completely out. But we move all the way across the image, and this is moving one pixel at a time, doing this all the way across, and it's putting these numbers into its own little vector. So we go all the way across, and we get to the face parts of the mouse. And when we do the math, we're going to get to 0. And the reason why is, yeah, there's a curve here, but this curve right here is not a concrete, literal representation of this curve. And so there's no math that adds up. If you were to do all the multiplication here, it would get to 0. And so as you're moving across the image, each one of these is being filled into its own little box. And I'll show you a little image right here. So the blue moving across is the filter doing the curve detection. The gray on the left-hand side is the image of the mouse. And this pink salmon-looking color is the new vector that's coming from this. So in this particular blue, it's doing some form of feature detection. So it's moving across the image from left to right, top to bottom, and this stride is 1, so it's just setting across, and every time it's doing its math, it's adding it to its own new vector. So that's why when we're doing this feature detection right here, it's important to know that the closer it is to the actual feature detection, the higher the number. So looking at this, we could, surmise that this is closer to the feature than these 2's are. And to give you just a slightly better idea of what I mean by like feature detection is that there's these filters, and the filter for edge detection could be something like this. So the brighter the color, the white is, the higher the number is. When it's black, it's either 0 or a negative. And so you can see that there's different types of filters, and the CNN just applies it constantly. Just as there's hundreds of these, thousands of these, being fired across this one specific image a bunch of times, trying to figure out what these features of this image that's labeled as a mouse would be. And so you can see that there's a handful of examples. And if we scroll a little farther, I'm going to show you an actual animation of this. So you can see that there's a red and a green box that's running across the image of this building. In the building, it's looking for kind of like this / edge, and then kind of like a / edge. And so as this convolutional neural net, these are 2 separate convolutional layers. So the green convolutional layer is firing off, looking for all the math that adds up to the highest number for a /. The red is trying to run across the image, looking for the highest amount of the /. So, So what we're looking at is trying to figure out where are these edges, where are these, particular features that may be adding up to that. And every time it's doing that, it's creating a new vector. So there's tons and tons and tons of this happening, and all this feature mapping is being done at all these different layers, different angles, different little crooks and circles, and the convolutional neural net is trying to figure out what makes this image tick to be a dog or a mouse or whatever it is. And so this is just kind of like the not the in the weeds math of how to do this, but this is like the explanation of how CNNs in general deep dive for convolution, not deep dive, how they do feature detection for CNNs. So now let's go ahead and talk about pooling layers.